Okay, so you hopefully have one of these papers with all these problems written out on it. If you don't, I can give you one. But the reason you've got problems written out as opposed to me making you write them with a pencil like usual is not because I want to honor your laziness, but because what we're going to work on is how to convert sentences into equations and then solve them. So all the problems you're going to be working on right here at the beginning are going to be the dreaded word problem. In which you must take English and turn it into math. And these problems, although you may hate them, is one of the most important things you learn in math because this is how people actually talk when you want to do math. I don't mean like literally these problems, but it's important to be able to convert English into math because if you're trying to find the best price to pay for something or how much you should invest in your business, nobody is going to hand you an equation. It's going to be English and you got to convert it. So one of the things we're going to start off with is getting used to some of the math words that you will need to be able to convert. Let's go ahead and look at this first problem. The sum of a number and 8 is doubled. So let's start off with the second word, sum. What does sum mean?
Addition.
That is addition. Exactly right. Now when we say a number, what are we talking about? How can I convert that, a number, into math? Yeah, a number is a variable. A variable is whenever you know that it's a number, but you don't know what the number is. You use a variable. Okay, moving on. What about doubled?
Times 2.
That means times 2. Okay, so let's just see if we can convert. Oops, sorry. Let's just see if we can convert that first sentence there into math. So the sum of a number and 8. Sum means add. A number is a variable, and then 8, of course, is the number 8. Now for variable, you can use whatever you want. I think x is a fairly common variable to use, but I'm going to use n for number. So the sum of a number and 8 means I take n and 8 and I add them together. That's the sum. Is doubled means times 2. Why would it be wrong for me to write that? Why is that incorrect?
Because that could look like a variable.
It could look like a variable?
Sure.
You mean the x?
Yeah.
Oh, okay. Let's change it to a dot then. That's still wrong. Why?
So it would just be n plus 16, right?
That would be n plus 16. Is that what I want to do? Do I want to double the 8?
Yeah.
Yeah, but I don't want to double only the 8, right? I want to double the sum. It says the sum is doubled. How can I double the whole sum?
Put it in parentheses.
Parentheses. There we go. That says double the whole thing, the 8 and the n. Great. Okay, moving on. Next, the result is. What is that? That's equals. The result is 12 more than. You might be tempted to say 12 more than is 12 plus. But I don't want you to think of it like that. I want you to think of it as plus 12. If I said, your grade is 12 more than mine, you would take my grade and add 12, right?
Mm-hmm.
That's how you would think about it naturally. Now with more than, it doesn't matter if you do 12 plus or plus 12. The reason I want you to get into the habit of writing that as plus 12 though is because when we get to less than in a little bit, less than has to be minus 12. 12 minus is something totally different. So just get in the habit of plus 12 minus 12. Okay, it's 12 more than what? The number. What was the number?
Variable.
That was the variable. The same variable. Okay, so let's see if we can convert this into math. The result is, that's equals. So equals. 12 more than means plus 12.
So it'd be
X plus 12 is okay, but we used n, so it'll be n plus 12. This is 12 more than the number. 12 more than the number. Now what we're actually asked to do is find the number. So we're going to use some of your sweet, sweet solve an equation skills. How do I solve this? Let's distribute the 2 first of all. That's a good plan. Now normally you're used to the 2 being in front, but it's okay if it's on the back. I just want to double both things. 2 times n and 2 times 8. So 2n plus 16 equals n plus 12. And then
So move the end from one side to the other.
that's a good idea. We could subtract 2n on both sides, or we could subtract n on both sides. Which one do you like better?
Subtraction.
I like subtracting n also. I like it because we keep everything positive, and also because now the n's are over on the left side, which is handy.
Quick question.
Yes, sir.
When adding and plussing, in this case, the variable, if you have 1x minus 1x, 1x minus 1x, does x disappear?
Yep, it's gone. 1x minus 1x is 0. Disappears. Okay, I've run out of space here, so I'm going to continue up here. What do I do next?
You carry the 16.
Yeah, let's subtract that 16 on both sides. N equals, and 12 minus 16 is negative 4. So what's the number? The number is negative 4. And we can go back and check by using this original equation with negative 4 in place of n. So let's try it. Let's look at the left side. Negative 4 plus 8 is? That's 4 plus 8. What's negative 4 plus 8?
4.
4 times 2?
8.
So this side's 8. Let's come over here. What's negative 4 plus 12?
8.
Also 8. The two sides are both 8. That tells me negative 4 is the correct answer. Okay, let's move on. A little bit different vocabulary here. The difference. What does difference mean?
Subtraction.
That means subtract. Okay, now this is weird. Between 2 positive integers.
2.
Yeah, 2 numbers, but I don't know what either one of the numbers are, so this is going to be 2 variables. Integers means what?
Number.
Yeah, numbers. Really, it means numbers that are not decimals or fractions. Now here is a valuable word, is. What does is mean?
It's definite.
Yeah, well, so what's the symbol that I use for that? This is equals. Okay, so the difference between 2 variables is 42. That means if I subtract 2 numbers, the answer is 42. So what are we going to call our 2 numbers? I need 2 variables this time, right?
X and A.
X and A. That's weird, but all right.
I don't know.
X minus A is 42.
That looks weird. Do X and Y.
Nope, too late. We're committed. X minus, you said X and A. That's it. No going back now. I'm writing in pen.
They have erasable pen.
You're stuck. They do have a erasable pen, but this is not one of those. Okay, here we go again. One integer is. There's is again. This is going to be one of my variables equals. Integer is. This is pretty self-explanatory. 3 times as great. That means times 3. Surprise, surprise. As the other, that means the other variable. Okay? So this is a completely separate equation. One integer is, well, I have 2 of them. I had x and a. Let's just pick one. I'm going to say x. One integer is 3 times as great as the other. So 3 times the other one. The other one was a, right? So 3 times a. Find the integers. One number's 3 times the size of the other, and when I subtract them, I get 42. So like, for example, if I said one of my numbers was 4, the other number would be 12. 3 times that number. 4 times 3 is 12. But that can't be it, because 12 minus 4 isn't 42. Does that make sense? That's why it can't be 4 and 12, because 12 minus 4 is not 42. You with me? Okay, so how do I actually solve this? Well, I want you to notice that I'm telling you right here that x and 3a are the same thing. X and 3a are equal, which means up here in this problem, I could replace that x with a 3a. So instead of x minus a, I could do 3a minus a equals 42. This is called substitution. We've done this before with just numbers, but now we're doing it with variables. Substituting variables. This is a fairly simple problem, right? One integer was 3 times as great as the other, so x was 3 times bigger than a. And then I replaced this x with 3a. So 3a minus a is 2a. And then divide 2. So a equals 21. That tells me one of the integers was 21. What's the other one going to be? What's x going to be if a is 21? So I could take this, a equals 21, and put it right there. Do substitution again. X equals 3 times 21, which as you just said is 63. So my two numbers are 21 and 63. And we can verify that. Is 63 3 times bigger than 21? Yes. If I subtract them, do I get 42? 63 minus 21, 42?
Yep.
Yes, it is. Good. You with me so far?
Okay.
All right. Let's do a little more worldy word problems here. Let's talk about hotel rooms. When you walk down a hotel, every hotel I've ever been in, the odds are on one side of the hallway and the evens are on the other side of the hallway. So the odd side goes consecutive odd numbers, consecutive meaning in a row. So one side of the hallway might have rooms 1, 3, 5, 7, 9, 11, and the other side has 2, 4, 6, 8, 10, etc. Okay, so if I'm looking at the room numbers of two adjacent hotel rooms, what does adjacent mean?
Next one.
Next to each other, they are two consecutive odd numbers. So an example of two consecutive odd numbers might be something like 21 and 23. Those are odd numbers that are one after the other. I skipped 22 because it's even, but those are two odd numbers in a row. Does that make sense?
Yep.
I know 21 and 23 can't be the answers. Why not? Other than because I just made them up. How do I know those can't be the two numbers? What's the next sentence say? Their sum is 1380. Refresh my memory. What did sum mean? Adam. If I do 21 plus 23, do I get 1,380? No, I don't. I'm off by quite a bit. Now, I could just keep guessing numbers. I could be like, okay, what if one of the numbers was 671 and the other was 673? Would that work? Maybe. And if it doesn't work, let's try a different pair. But I could be sitting here trying numbers for a long time, so let's do better than that. Notice what's happening here with these two numbers. How far apart are they? They're 2 units apart. This is 21. If I add 2, I get 23. So if I told you the first number in my row was 35, the next number would be... And I assume that you did not get that by doing counting off the odd numbers. You took the number that I gave you and you add 2. If I tell you the first number is 43, the next one is 45. You take the number I give you and you add 2. Now, I don't know what the first number is. I don't know what the first room is. So let's call it R for room. If I told you the first room number was R, what would the second room number be? Well, you take the one I gave you and you add 2. It'd be R plus 2. So this is the first room. And this is the second room. Does that make sense? If they're consecutive odds, the second room is 2 numbers bigger than the first. Does that make sense? Well, now it's pretty easy. If I add these 2 rooms together, I should get 1380. So the first room plus the second room should have a sum of 1,380. All right, my little algebra experts, take it away. What do I do?
Do the brackets first.
Yeah, I'd like to do R plus 2. Can't combine them though, because one's an R and one's just a number. So, do I even need these parentheses? I don't think so. Those parentheses aren't doing anything for me. I can't even do distributive property because there's nothing out in front of the parentheses. So those parentheses are just kind of useless. Now what?
And to do variables.
Yeah, let's add the variables. R plus R, 2R plus 2 equals 1380. And now we're home free, aren't we? What do we do?
Subtract 2.
Subtract 2, that's a good plan. So I get 2R equals 1378. Ran out of space here. Let's continue over in the next column. Oops. Now what?
Divide by 2.
Divide by 2. That's a great idea. You may need a calculator for this. That's totally fine. There's no shame in using a calculator. I mean, we are going to mock you incessantly, so I guess there is a little bit of shame in it. One of our rooms is 689. Unless I divided wrong, which would be a tragic embarrassment. The problem says find the hotel room numbers, meaning we need both. If one of them is 689, what's the other one?
That's 2 off.
Yeah, it's 2 off, so...
That's more.
Well, R was 689. That was the first room, was R. Second room is R plus 2, so 689 plus 2. 691. On the 6th floor of the hotel, I presume. I stayed in a hotel over the summer that did not have a 13th floor. When you got onto the elevator, it went like 11, 12, 14, 15.
There's a reason for that.
What's the reason? Superstition? That seems dumb. People on the 14th floor have to know the truth, right?
Sure.
If you're on the 14th floor, you got to know like you're on the 13th floor.
What's the superstition behind that?
I don't know. I guess people don't like the number 13.
Just don't count it as you go up.
I got a notebook for class.
Good. Did you get lost on the way here? We started 30 minutes ago.
I wanted to get a notebook.
You got a notebook but no pencil. You are my inspiration. All right, let's try another one of these. When you open a book, the left and right page numbers are 2 consecutive natural integers. So books always start with, if I were like to open a book like this, the odd numbers are always on the right page and the even number is always on the left page when you open up a book. So like for example, if this page was number 21, this page would be number 20, right? I assume you kids still read books every now and then.
Sure.
Yeah.
This is similar to the last problem, except since they're not odd numbers, they're just numbers. I know the second page is 1 higher than the first page. So if I said, hey, I'm looking on the left side and it's page number 140, the right side would have to be 141. You just add 1. So this is very similar to the last one. I'm going to call the first one P. That'll be my first page. So the second page then would be P plus 1. Very good. That is the second page. And what am I told? I'm told that the sum of the page numbers is 349. So what's that equation going to look like? The answer to what, though? What's the first part of this going to look like? The sum of the page numbers. What's the first page number?
Would it be P plus P plus 1?
There's the first one, plus the second one is 349. Great. Now we're home free. I don't really need the parentheses, right? Because there's nothing to distribute. Add the variables. That would give me 2p, or not 2p. And then minus 1. Good idea. You are a smart fellow. I should take back some of the bad things I've been saying about you behind your back. So 2p equals 348. I'm one step away from sweet, sweet glory. Division. So the number that I'm going to get is going to be even. It's going to be an even number because it's an even divided by an even. So the first page, which was the page on the left, is 174. So what's the second page on the right going to be? 175, and I can check this by making sure that 174 and 175 added together is 349. And it is. You all right about this? So far, so good? All right. Let's get tricky. Now, one of the hard parts of these problems is actually naming the variables, deciding what should be a variable. So let's practice that with this question number 5. A college graduating class is made up of 450 students. There are 206 more girls than boys. How many boys are in the class? Even though the problem's really just asking me about boys, I am going to need a variable for the girls as well because I don't know how many girls there are. Okay, so I'm going to need one variable for girls and I'm going to need a different variable for boys. Okay, so just to keep things simple, girls, we're going to use the letter B, and boys, we're going to use the letter G. I feel like that's probably the simplest way to do that. G for boys and B for girls?
Yeah.
Yeah? Obviously, that is a terrible idea. Since variables can be any letter you want, use letters that make sense. Let's say G is the number of girls. Don't get stuck where you're like, but it's math. I need to use X and Y. No, you don't. Use whatever you want. If you use X and Y, then you have to remember for the entire problem, okay, X, which one was X again? Did I make that boys or did I make that girls? If you use G and B, you just know G is girls because, write this down, kids, girls starts with the letter G. Okay, so the college graduating class is made up of 450 students. Can someone say that to me in math? Talk math to me.
Does that mean equal 450?
What equals 450?
The variables.
Yeah, the variables when I do what with them?
Add.
Yep. This means the girls that graduated plus the boys that graduated is 450. That's your graduating class. Girls plus boys equals 450. I suppose being 2019, we should say girls and not girls, but you get the idea. There are 206 more girls than boys. Now, this is tricky. More girls than boys. The number of girls has to be higher than the number of boys. So if I said there are 12 boys, what would you do to get the number of girls?
And 206.
I would add 206 to what?
The number of
The number of boys, and that tells me, this is audience participation time, and that tells me
How many?
how many
how many more?
glittering and girl boys plus 206 gives me girls.
Yes.
So boys plus 206 equals girls. This is very tricky because when the problem says there are more girls than boys, your instinct is to say, oh, I should add 206 to girls because there are more girls. But that's not what this equation's saying. Girls are higher. We have to add on to the boys in order for them to be equal. The boys are lower, so as in life, we got to help the boys out to make them as good as the girls. Help them out to the tune of 206 in this case. Okay, so now we're ready to do some substitution. Girls is equivalent to boys plus 206. So I'm going to come up to this problem and replace the G with boys plus 206. So instead of G plus B, I'm going to do B plus 206, that's my girls, plus B equals 450. And that substitution is the tricky part of this problem. You can get substitution down, you're in good shape. All right, now what?
So it would be 2b plus 206.
Okay, so 2b plus 206 equals 450. Great job. Okay, how do I isolate b? How do I figure out what it is?
Subtract 2.
I'm going to subtract 206 from both sides. That is an excellent plan. So I get 2b equals 244. Yep, division. Divide both sides by 2. So b equals
122.
122. 122, though, is the number of...
So you do 122 minus 450.
Hold on. What is 122 the number of?
Boys.
Boys. And the problem asked me to find...
The boys.
That problem asked me to find boys. I'm done. How many boys are in the class? I'm done. If the problem said how many girls are there, I'd do 450 minus 122.
Well, in this case, would be if you had 206 more girls, you would have that for 122.
I could do 122 plus 206 to get the girls. Yes, sir.
Yeah.
So 328 plus 122 should give me 450 if we did it correctly. Many, many, many more girls than boys, just like all of the parties that I throw. I'm just kidding. I don't throw parties. Number 6, a 22-foot pipe is cut into 2 pieces. All right, so let's draw the pipe. There's the pipe. I cut it into 2 pieces. I know it's not cut exactly in half because over here I refer to the shorter piece. So I don't know where it's cut. I'm just going to guess. Cut it right there. So I got a short piece and a long piece. Now here's what I know. The short piece is 7 feet shorter than the long piece. What's the length of the long piece? Now it doesn't feel like I have enough information here, but don't forget we were told it's 22 feet total. So the whole thing is 22 feet. So for example, if I said the short piece was 1 foot long, how long would the long piece be? If I said this was 1, what would this be? 21, right? I know that can't be true though, because the short piece is only 7 feet shorter than the long piece, and 1 and 21 means it's 20 feet shorter than the long piece. Does that make sense?
So we just minus 7 from 22.
If I minus 7 from 22, I'd have 15. So if the long piece is 15, the short piece would be 8, right? 15 minus 7 would be 8.
Mhm.
And 15 and 8 is a total of 23, not 22.
Oh,
Could you just divide it by 2 and then subtract 7?
If I divide it by 2, that would give me 11. Minus 7 would be 4. If the short piece is 4, the long piece would be 7 more than that, which is 11. 4 and 11 does not have a sum of 22. I appreciate that your immediate thought process on this problem is, I wonder if I can guess the answer instead of doing algebra. Unfortunately, it seems like that is not the case. So let's assign our variables. We need a variable for the short piece and the long piece. So I'm going to say S is the length of the short piece. And L is going to be the length of the long piece. Long piece. Okay. All right, help me out here. What do I know?
so you have 2 measurements here.
Yeah. I know the whole pipe is 22. Can I write an equation that uses that?
Equals 22?
What equals 22?
7.
S plus L.
There we go. Yeah, if I add the 2 pieces together, that should be 22, right? If the whole pipe's 22, then short plus long should be 22.
And then you do S plus 7 plus L.
Yeah, S plus 7 equals L is a great way to write it. I was actually thinking doing subtraction because it says shorter than. Your way works. I want to show the other way though. The shorter piece is, what does is mean? I forgot. Equals. So the shorter piece is 7 feet shorter than. This is like when I was talking on the front side about greater than. Greater than, we would say plus 7. Shorter than, we're going to do minus 7. So 7 feet shorter than minus 7. Shorter than what? The long piece. And here's our substitution again. S and L minus 7 are interchangeable. So I can replace the S with L minus 7 using substitution. So instead of S plus L, I'm going to do L minus 7 plus L equals 22. Okay, how do I solve that?
Get rid of your brackets.
Yep. I don't really need those, do I? The parentheses?
2L minus 7.
I don't need the parentheses because there's nothing out in front of them to distribute. That's why I can just drop them. And then we can combine the L's. That would be 2L minus 7. And then, I'm already subtracting 7, so add 7. So 2L equals 29. And I'm running out of space, but I bet we can squeeze it in here. Divided by 2, divided by 2. 29 divided by 2 is 14.5 or 14.5. And that's the reason why we were unlikely to guess the correct answer just by picking numbers, because I think it would have taken us a long time before we started guessing fractions. But if the long piece is 14.5, the short piece would be 7.5, 7 less than that. And 14.5 plus 7.5 is 22. Now L was the long piece. What did the problem actually ask for?
The length of the longer piece.
It asks for
Long.
the length of the longer piece. So I already got it. So pay attention when you're doing these. Make sure you answer the question that's being asked. Don't do more work than you need to. Okay, one more. Let's talk about our pal, the triangle. A triangle has three angles, A, B, and C. Let's go ahead and draw your best triangle. And I'm going to call the triangles A, B, and C. So right away, I've got three different variables because the triangle has three different angles. What are we going to do? I don't think one of those angles is 180, but I think all three of them together is 180. In fact, I didn't know if you were familiar with that or not, so I wrote it at the end of the problem. The sum of the angles of a triangle is 180, meaning angle A plus angle B plus angle C is 180 degrees. It's not. Pythagorean theorem is about sides, not angles, but it does use the A, B, and C. Just a coincidence, though. All right, well, let's look at the second sentence here. Angle C is 18 greater than angle B. So here we go. Angle C is, what does that look like? C is 18 greater than means plus 18. 18 greater than what?
B.
B. Good. And then let's look at the next sentence. Angle A is 4 times angle B. So angle A is 4 times angle B. Yeah, B times 4 or 4B. Or not 4B. Okay, so we've got three equations. This seems like a nightmare. I don't want to. I'm scared. But notice that C can be replaced with B plus 18. Notice also that A can be replaced with 4B. If I did that, this original equation, A plus B plus C equals 180, would have nothing but B's in it. Let me show you. Instead of A, I'm going to do 4B. Plus B, plus, and instead of C, I'm going to do B plus 18 equals 180. Go ahead. Highlight these so you can see where they came from. So I just took a problem that was kind of a nightmare because we had three equations with three variables, and now we've rewritten it where we've got one equation with one variable. I can solve this. It's going to take some work, but I can do it. Let's combine the b's. 4b, 1b, and b is 6b plus 18 equals 180. Subtract 18. Six B equals 162. Good. Then what? Divide 6. So B equals 27. I hope. That's only one of the angles, though.
Yeah.
And then you do
But the other ones are really easy now that I know B.
A equals
B is 27.
4
Remember, A was 4 times B. So A is going to be 4 times 27. Uh, 4 times 27 is 108. And it's also really easy to figure out angle C, because angle C was B plus 18, and I know that B is 27, so C equals 27 plus 18, which means C is equal to 45. And then I could check and make sure that I knew what I was doing by adding C plus A plus B, adding all three of those together to see if it equals 180. You can take my word for it, it does. So a lot of these problems, the way, especially if you have more than one equation, a lot of these problems are going to be solved using substitution, which is what we've done in the last several. Substitute variables so that you only have one variable in your equation. If I give you an equation with 3 variables in it, there's no way you can solve that. You can't even solve an equation that has 2 variables in it. But if your equation just has 1 variable in it, we can solve that. And once you solve one, it's like the dominoes all fall down. Once you know one, it's real easy to get the rest. Does anybody have any questions on converting these word problems into equations and solving them?